Hello, today I'm going to show you how to derive the SUVAT equations. So what are the SUVAT equations? They're a set of equations that describe the motion of a body moving under constant acceleration. So it's the only condition we have is that the acceleration doesn't change. So let's have a look at what the SUVAT actually stands for. So it's all the variables that we have. We have 5 of them, where S stands for the displacement. Why it's S, I'm not entirely sure, use quite a lot though. U is initial velocity, V is the final velocity, A is acceleration, and T is time. Beautiful. So we need a few things before we can begin this derivation. We need the definition, I suppose, of acceleration, which the acceleration is the change in velocity over the change in time. And then also the idea that velocity, so not the idea, but the equation that velocity is equal to displacement over time. Beautiful. So for the first equation, all we're going to do is we're going to have a look at our definition for acceleration, but rewrite it in terms of the variables that we've got defined over here. So A stays the same, it's still acceleration, is equal to then the change in velocity. Well, that's going to be the difference between the final and the initial. So V minus U, and then all divided by T. Rearranging that, we bring the T up. So V minus U is equal to AT. And then we add the U to both sides. So that gives us our first equation, that V is equal to U plus AT. Very nice. The second equation then is going to come about by having a look at the velocity displacement time equation and filling in basically what we have. So this is actually kind of true for the average velocity over the period, over the time. And we can think about now we have a constant acceleration. So our velocity time graph, if we have time over there, velocity up this axis, what we're saying is basically this is a straight line. It doesn't have to be flat, doesn't have to be increasing, could be decreasing, any gradient basically. But it's a straight line. So what that means is then to work out our average, it's just the first and the last and divided by 2. In the same way, like to work out the average height, you'd do first and last divided by 2. The average velocity will be the same manner here. There's nothing changing. So thinking about this equation then, average velocity, initial plus final divided by 2. Displacement divided by time, S over T. We rearrange this then to make S the subject, and S is U plus V over 2, all times by T. Very nice indeed. So that's our second equation. For the third then, and the fourth, and the fifth, what we're going to do is we're going to take this initial equation, equation 1, and substitute it into equation 2. So you can see we have U, V, and T on the right hand side, and we're going to rearrange it over here. So we can say that U is equal to V minus AT, and also if we rearrange for T, that T is equal to V minus U divided by A. So let's first start by replacing V. And what do we get then? Well, S is equal to U plus AT, all divided by 2, and the whole thing times by T. Expanding this out then, we collect the like terms, there's 2 U's there, divided by 2 gives us a single U, times by T gives us UT. In terms of the ATs, we have AT here, times by T is AT squared, so we have half AT squared. That's equation number 3. Equation number 4, very similar, but now we'll replace the U with V minus AT. So we've got V minus AT plus V all over 2 multiplied by T. And we can see this is very similar here. We've got 2 V's minus AT instead of a plus AT. That's the only difference. So it's going to be VT minus half AT squared. So yeah, very similar. Sometimes you won't see this equation. It's the one that's ignored if there's only 4 given instead of 5. The final equation then, we're going to replace replace the T in this equation, in equation 2. So what we get is that S is equal to U plus V over 2 times by V minus U over A. The numerator is the difference of 2 squares. So we have that it's V squared minus U squared. We can see that if you just expand this out, you'll have UV plus V squared minus u squared and plus another, well, minus a uv as well. So those two will cancel off. And you're left with just v squared minus u squared. The denominators, multiplying them, we get 2a. So we can multiply by the 2a and rearrange this to say that v squared is equal to u squared plus 2as. And that's our fifth equation.